Well, howdy there, Internet students. It's Mr. Hermanson again. Today we're going to start Unit 7.3, Systems of Equations. And our focus today will be on learning how to um, make sure that a solution works for a system of equations. So basically, what is a solution to a system of equations? So let's head to the next page. These are the objectives. And let's start by just thinking about a problem. Farmer Melvin has a farm with chickens and cows. He took a recent head count and found there were 81 animal heads. Find three possible combinations of chickens and cows he might have on this farm. So go ahead and see if you can figure out three possible combinations. And so pause now so that we can keep moving and you can be thinking about it as we go. All right, here's my answers. And I thought it'd be easier if I use an ordered pair to show my chickens and cows. So X is how many chickens I'm saying there is, and Y is how many cows. So if we have one chicken, and then we would have 80 cows because each chicken and each cow has one head. So, or we could have two chickens, 79 cows, 40 chickens, 41 cows. I'm sure you came up with other possibilities. You can see that there's many possibilities. Okay, so if X is the number of chickens, like I said, and Y is the number of cows, what equation would represent the total number of animal heads on the farm? So what is the relationship between these two numbers? Go ahead and write that as an equation. This would be a good time to pause. You should be thinking that if we add our chicken heads plus our cow heads, we're going to get 81. So X plus Y equals 81. Now, Farmer Melvin's wife, Eleanor, counted a little differently. She counted how many legs there are on the farm. So how many total chicken legs and cow legs. And she found there's 252 legs. Go ahead and find three possible combinations of chickens and cows that could have 252 legs. Pause, and I'll get back to you on that. Well, here's three that I found. Now, to verify that these are correct, now remember that my first number is chicken, so I would have to do for this last one here 10 times 2, because each chicken has 2 legs, and that would equal 20. 53 times 4, because each cow has 4 legs, so that'd be 220, and 12 is 232. I think I did my math wrong on that one. I'm going to have to change that answer. That one would be 58, I believe. So 58 times 4 is 232. So then add those two together. These are all the legs. So 20 plus 232 is 252 legs. So that one works. So to verify them, you multiply the number of chickens, the first number times 2, plus the second number times 1. And if that totals 252, then it's a possible combination. So if X is the number of chickens and Y is the number of cows, what equation represents the number of animal legs on this farm? Think about that, write down your answer, pause now, and then come back and see if you got it right. If you were thinking that you would multiply the number of chickens times 2, X is the number of chickens, remember, plus the number of cows times 4 to get the total number of legs, which equals 252, you are correct. All right, now to find the actual number of chickens and cows that Melvin and Eleanor have, you would have to find a common solution to both equations. Both of those two equations we wrote, the one that represents counting heads and the other one that represents counting legs. And in this investigation, we're going to try and figure out some ways to solve that. Right now, I think the only way you would be able to do that is if you sort of guess. So if you pause now and you want to figure out what the answer is that works for both those equations, go ahead and do that. Well, if you figured out that there's 36 chickens, remember that's X, and there's 45 cows, that's your y, you are correct. Now the way you would check that is you would make sure that 36 and 45 work for this equation. So 36 plus 45 equals 81, which is true. That doesn't necessarily mean it's the solution for both equations, though. We need it to also work in the second equation right here. So we need 2 times 36 plus 4 times 45 to equal 252. So 2 times 36 is 72, 4 times 45 is 180, 72 plus 180 equals 252. So we are true for both, which means we have found the common solution. We have solved the problem. To me, this is kind of amazing math that you can do this. So if you can write two equations with two different variables, the same two variables, and you can find the common solution. Now we're going to learn some ways of doing that. For today, though, I would like you to be able to just tell whether or not a pair of numbers is a common solution to two equations or a system of equations. All right, so for this part of the lessons, we're going to switch over to the practice that you're going to do today, and I'm just going to get you started on that. Basically, these are multiple choice answers. One of the answers is the correct choice, and what you're going to do is test the solutions till you find the one that works. So I'll get you started on that. Let's test A here. And to test A, remember that the first number in the ordered pair is X, the second number is Y. So what we're saying is that X is -1 and Y is -10 here. All right, and so what we're going to do is just substitute those numbers in to the two equations. So I'll do my work up on this right side here. So we have the first equation is y equals 3x plus 7. Now we're going to put -1 where the x is. And we're going to put -10 where the y is. And we get -10 equals -3 plus 7. Now, that is not true because -3 plus 7 is actually equal to 4. And -10 is not equal to 4. So that is not the correct solution. So then we're going to move on to the next one. We'll try B here. So in B, x is -17, y is -8. So let's try that in the first equation. Y equals, so y is -8. We're going to put that where the y is, and we're going to do 3 times -17 plus 7. And that would say -8 equals -51 plus 7. There's no way that one's not working. Let's move on to C. So trying it in the first equation, y equals 3x plus 7. We get 19 equals 3 times 4 plus 7. That is true, because 3 plus 4 is 12, plus 7 is 19. Now, that isn't enough, though. It has to work for the second equation also. So we're going to put 4 and 19 into the second equation, which is y equals x minus 9. We're going to put 19 where the y is, and we're going to put 4 where the x is. And 4 minus 9 is -5. It doesn't work for that one, so it's not that one. It must be D, and I'll show you that that works. If I take the first equation, I get -17 equals 3 times -8 plus 7. And that's -24 plus 7, which is the same as -17, so that works. The second equation, y equals x minus 9. If I put negative 17 where the y is, negative 8 where the x is, and do this subtraction. That equals negative 17. That works for that equation also. So the common solution is D for both those equations. Now, down here on number 7, I just want to talk about that real quick. An equation will have no solution if there's no possible way for a number to, for the same number to work for both equations, the same two numbers. The situation we had up at the top was there was one solution for the equation. That usually happens. Now, if any number works no matter what you put in it, then that means there's an infinite number of solutions. All right, so in number 7, I'm going to give you the answer to this. Notice it says y is equal to 5x minus 4, and then y is equal to 5x minus 5. Well, if you have 5x and you subtract 4, how can that be the same as 5x minus 5 if you're using the same x? The bottom equation is always one less than the top one. They're never going to be equal. So this one has no solutions. All right. And on number 9, the answers are given for you. I'm just going to show you quick how you write the system of equations for 9, 10, 11. In fact, I'm just going to give you the systems. I'll talk you through this first one, and then I'll write down the other one for 10 and 11 that you're going to use to check. It says the length of a rectangle is 3 centimeters more than 3 times the width. So let's say y is the length. Y is 3 centimeters more, so plus 3 times the width, and we'll have x be the width. And then it says if the perimeter of the rectangle is 46, now to find the perimeter, you need 2 x's plus 2 y's, because you're adding up all 4 sides of the rectangle. And that would be 46. So that would be the 2 equations that make up that one. Now, the other ones I'm not going to talk my way through. I'll just write down the equations you can use, and then you're going to just find the correct solution. Here's the 2 equations for number 10. Now, if you're not understanding the equation, don't worry about it. We're going to be learning how to write the equations later in this unit. For right now, we're just practicing learning how to tell if solutions work for an equation. All right, so there you are, the last system. Go ahead and figure out what you think are the correct answers for each of these problems, and you're going to submit those answers on a Google form then. All right, good luck. Talk to you later.